Welcome to Probability and Statistics. In this lecture video, we're going to talk about the process of a statistical study. And I got quite a few words here. I'm going to define them for you in this section. Alright, let's take a look at the different types of study. One of them is called the observational study. You observe data that already exist. So that means somebody else probably already collecting the data, and we're just making an observational study. Alright, an experiment. Okay, I use this word quite often in chapter 4. An experiment generates data to help identify the cause and effect relationships. A representative sample. Alright, this is a sample. Has the same relevant characteristic as the population, and it does not favor one group from the population over another. Your sample that you collect, the data that you collect, those samples got to be representative. Okay, it got to have the same relevant characteristic as the population, because otherwise, if your sample is not representative, that kind of defeat the whole purpose of collecting the data. So for example, using the 2016 election, Donald Trump versus Hillary Clinton, the data, the exit poll, may not be very representative type of sample. It might favoring it might be, when they collecting the data, it might be favoring Hillary Clinton to win the election over Donald Trump. Okay, that could be one of the case. I'm going to give you an example real quick. Determine whether an observational or experimental study is appropriate. So a deli cart entrepreneur wants to find out if her customer base is shrinking. Alright. The deli cart entrepreneur wants to find out if her customer base is shrinking. Is this an experimental study or an observational? In this case, this will be an observational. Okay, because the entrepreneur is not trying to generate data to identify the cause and effect relationship. Okay, she is just making an observation. Alright, before we talk more about each type of study, observational and experimental study, I want to talk to you about what is so-called the sampling method. Okay, different way we can take in samples. The best one is the random sampling. It is a process of using chance to select from the population to be in the sample. It's called the random sampling. Alright, and I love this picture that we have in the textbook. Random sampling when you're playing bingo. Why random sampling? Because what we want to do always is trying to avoid being biased while we're collecting data. Alright, so the concept here is a sample size lowercase n from a population size capital letter N is obtained through simple random sampling. So the word simple random sampling means every possible sample size lowercase n has an equal likely chance of occurring. Okay, everybody in that sample size has the equal likely chance of occurring. So the data that we collected will be called the simple random sample. Alright, kind of tongue twister, a lot of simple random sample, a lot of those kind of wording. All that's saying here is we want every sample inside the size lowercase n has an equal likely chance of occurring. Alright, this concept called the sampling without replacement is once an object selected, it will be removed from the population. So for example, I can draw a card from the standard deck, the one that I draw, if I don't put it back in the deck, that will be without replacement. If I put the card that I draw back into the deck, that will be called sampling with replacement. Alright, we'll talk about these two words in a later chapter. And the question is, why with replacement or without replacement matters so much? Because it will actually change the probability of occurring. If you draw a card out, okay, if you draw a card out, let's just say, for example, let's say we're going to draw 2 ace from the deck. This is with replacement. If I draw 2 cards, I want to draw 2 aces with replacements, the chance of drawing the first ace got to be 4 out of 52. With replacement means my second draw, I should still have 4 ace in the deck, because with replacement means I will replace the card I drew back into the deck out of 52. Alright, so my second ace will still be 4 out of 52. Now, sampling without replacement. So if I want to draw an ace, without replacement, alright, my first card that I draw, I should have 4 ways to draw an ace out of 52. Without replacement means my next time I draw an ace, there should only be 3 ace left out of 51 cards left in the deck. So the probability changes, okay, between with replacement versus without replacement. Alright, so we want everything to be random sampling. Another type of sampling method is called the stratified sample. It is obtained by separating the population into non-overlapping groups and select randomly from each group. Okay, this is the key. We're going to select randomly from each group. So the picture here implies that, okay, I have 4 groups here, non-overlapping groups. From each group, I will randomly sample from each group. That's called stratified. Another similar one is called a cluster sample. It's obtained by selecting all the individuals within a randomly selected group. So as you can see the picture here, I have a lot. 1, 2, 3, 4, 5, 6, 7. I have 21 non-overlapping group. Okay, so once I separate them by non-overlapping group, then I'm going to randomly sample everything within that group. Okay, I'm going to randomly pick a group and sample everybody in the group. Versus stratify is stratify will be randomly selecting individuals from every group. Okay, but I'm not asking everybody in the group. If I sample everybody within the group, that will be the cluster. That's the difference between the two. Alright, another method is systematic samples. It's obtained by selecting every so many individual from the population. Okay, for example, every 4th bottle, we're going to take out every 4th bottle off the assembly line. Okay, and you're gonna hear this. You're gonna see this selecting every so many. That will be systematic. All right, very powerful sampling method for assembly lines. The last one is probably one of the worst ones, called a convenience sample. Alright, it is a sample in which individuals are easily obtained and not based on randomness. Okay. Alright, let's try some example here. Okay, if I need to, I will flip back to these pictures. Alright, identify the sampling technique. Alright, a random number generator is used to choose 5 districts. So I got 5 districts. So I'm going to use circles. 1, 2, 3, 4, 5. Then a college student collects data from each person in these districts. Alright, I'm going to select everybody. I'm going to sample everybody in this 5 district out of a lot of districts. So this random number generator it chooses 5 particular one. And then we're going to sample every person in these 5 group. In that case, that will be called the cluster sampling, because if I go back to this picture, cluster is selecting everybody within a randomly selected group. Okay, the number generator select the 5 group for me. I'm gonna selecting everybody in that group. That would be called cluster. Alright, a school administrator choose 10 people at random from each neighborhood. A school administrator chooses 10 people at random from each neighborhood. So that means the school, alright, the kids go to that school come from many different neighborhoods. Alright, they're gonna choose 10 people at random from each neighborhood. That means every neighborhood they're gonna choose 10 people at random. So that means we already have non-overlapping, and we're gonna choose 10 people from every neighborhood to be in the sample. That would be stratified. Sampling. Alright. First, the population is subdivided by class. Alright. Then a crime researcher uses a random number generator to select 15 members from each class to study. That's another example of stratified, because I already got non-overlapping group. That's called classes. And then they select 15 members from each class. So they're randomly selecting 15 people from all these classes. Okay, they are not surveying everybody from these classes. Okay. Because to be a clustered sample, you got to be this the entire group of people. Okay, gotta be in the sample. And which group do I pick is randomly selected group first. Okay, but everybody in there will be asked. That would be cluster. Stratify is randomly choose every member from all the classes or all the groups. Alright. A polling each member of the group you wish to study. So this is asking everybody in the group, okay, you wish to study. That would be called census. Okay, that's what the word means. Census is asking everybody in the group, okay, you want to study. Population census that we take every 10 years. will be polling the entire population, okay, of the United States. That's called the population census. That's everybody, which they're trying to get everybody. Alrighty. So I hope the different types of sampling technique kind of make sense. It's really playing on words. So I wish you can read this thing carefully and look at the pictures. Okay. The biggest issue that students run into is the difference between stratified versus clustered. Okay. All right. Let's take a look at what is so-called the observational study. Okay. So what we just talked about is called a sampling technique or sampling method. This is observational study. Under the types of observational study, we got several different types. All right. So one of them is called a cross-sectional study, where the data are collected at a single point in time. All right. It's a snapshot view, so that means anything like a Washington Post or ABC poll, different type of surveys. Okay, it's a snapshot view, so that means it's just that one-time study. That's it, one-time data collection. Okay, in a longitudinal study, the data are gathered by following a particular group over a period of time. So that means we select a group of people that we sample, and then we continuously, all right, asking them the whatever question that we are trying to gather. All right, so this data are being tracked. The perfect example will be in elementary school. I think at the end of the year you will take a standardized test, and that standardized test you took that every year in elementary school. I think starts at 3rd grade or 4th grade. They track you over time, okay, because the 3rd grade you take it, 4th grade you take it, they compare your test score, see if you're doing better or doing worse. All right, and they collected almost everybody in the grade. All right, so those type of data, okay, those type of study, okay, it's called a longitudinal study. Particular group following particular group over a period of time. A meta-analysis study is a study that compiles information from previous studies. Okay, so that means a lot of people doing different studies. The meta-analysis will be something that using other people's study, put them all together. A case study looks at multiple variables that affects a single event. So this is a more in-depth study than the meta-analysis. Okay, case study is basically looking at particular things more in detail, more into it. Alright, let's give this a try. Let's see if it's a meta-analysis or a case study. Okay, 5 fish caught in the bay are measured to determine the overall health of the fish in the bay. 5 fish are caught. Okay, so this is going to be a case study. Alright, why is it going to be case study? Because case study, okay, looks at multiple variables that affects a single event. Okay, my single event is the health of the fish in the bay, and I'm using 5 particular or 5 fish that we caught from the bay. Okay. Alright, so this one right here, let me kind of show you the difference. A town council compares 3 newspaper articles about crime prevention. So they are looking at other people's study, okay, and trying to draw a conclusion. Alright, using other people's previous data, meta-analysis. Alright, because meta-analysis says it's a study that compiles information from previous studies. So now, let's pretend the study shows that crime prevention, one of the ways for crime prevention, let's pretend to be education. Okay, we're gonna have better education to prevent crime. Okay, so if the town council begin to look at the education, okay, of wherever they live, all right, looking at the test scores from the schools where they live, if you go a little bit more in depth, that can be a case study. So they can say, all right, we're gonna draw, we're gonna have a school here in this town. We have 3 neighborhoods. All right, so let's look at the education level of the 3 neighborhoods and then compare that to your crime rate. Okay, so if the neighborhood they selected has a higher education, has a higher test score, kids from that neighborhood has a higher test score, more likely they will probably have a less crime in that particular neighborhood. In that case, that would be called a case study. We are going more in depth into it. Okay, but if we're just gathering information from somewhere else, it's called the meta-analysis. All right, another type. Let me flip this back a little bit. Another type of statistical study is experiments. Okay, the one we just talked about is observational. All right, and the textbook shows us the principle of experimental design. What we want to do is randomize the control in the treatment groups, control for the outside effects on the response variable, and replicate the experiment many times to see a meaningful pattern. So this is a procedure. Okay, so what I want to talk about here is some of these words that you tend to hear from time to time. So for experiments, okay, statistical experiments, a treatment is some condition that is applied to a group of subjects in an experiment. So let's say we have a particular drug, okay, a particular drug that we need to push through the FDA. So the drug, okay, can be the treatment, okay, of whatever, maybe like trying to quit smoking or something. All right, treatment is a condition applied to a group of subjects in an experiment. Subjects are the people in being studied in an experiment. It can be people or things. Participants are people being studied in the experiment. What is so-called a response variable, all right, is the variable in an experiment that responds to the treatment. So that means this particular drug we have trying to help people quit smoking, okay, response variable is a variable in an experiment that responds to the treatment. So that means the subjects or the participant in the trying to quit smoking, okay, they actually respond to the medicine. So that means they probably they don't have as much desire to smoke once they take that particular medication. All right, explanatory variable is the variable in an experiment that causes the change in the response variable. It's a variable in the experiment that causes the change in the response variable. For example, here, let me kind of show you. All right, the medicine I was talking about is called Chintix. You've probably seen this on the commercial. All right, the whole point of that medication is trying to reduce the person's urge to smoke. So a response variable will be the urge to smoke. So that means they take the Chantix, they reduce the urge to smoke. That will be the response variable because they're taking the drugs, and it reduced the urge. All right. The explanatory variable is a variable in the experiment that caused the change. All right. What caused the change of the urge to smoke? What caused the reduce of the urge to smoke? Which is using the Chantix itself, using the medication itself. All right. I hope that makes sense. Some of these words can be a little bit strange. A control group is a group of subjects which no treatment is applied. You probably hear this a lot. A treatment group is a group of subjects to which researchers apply the treatment in the experiment. All right. A confound. You probably heard some of these words before. Confounding variable are factors other than the treatment that cause the effect on the subject of an experiment. So what that means is, for example, there's a lot of weight loss pills right there, out there right now. So if I want to do a weight loss pill, is using a weight loss pill reduce a person's weight? Okay, so if this magic pill can make me lose weight, all right, that would be awesome. But what does that confounding variable mean? That means other than the treatment itself. So I can lose weight by taking this pill. Confounding variable would be other factors, such as I could also eat healthy, I could exercise more, and I can have more motivations, okay, of being more active. All right, that can also cause me to lose weight. Other than the pill itself, that would be called a confounding variable. Other factors, okay, other different factors. All right, placebo is the substance that appears identical to the actual treatment but contains no intrinsic beneficial elements. Okay, you probably heard this word before. Placebo effect. Sometimes people can, people ask you to be in this weight loss, weight loss pill program, and they can give you a pill that appear to be the actual pill, but it actually contains no substance. Okay, and a lot of time, what the placebo effects shows that psychologically, if you think you are taking that medication, but you are not, you can actually still lose weight. Okay, that would be called the response to the power of suggestion. Okay, rather than the treatment itself. Psychologically, we think we are actually losing weight by taking this pill, but in fact we are not. It's just like a lot of times when you don't feel good, going to the doctors, and almost like when you sit in the doctor's office, you begin to feel better. That's called a placebo effect. It's kind of like that. All right, a single blind experiment, okay, is where the subject do not know if they are in the control group or the treatment group, but the people that are interacting with you knows. Double blind experiment is neither the subject or the people working with you know which group you are in. Okay, so double blind is probably the best in the experiment. Okay, so I just want to run through some of these words with you in this particular section. The key thing coming out of here is the different types of sampling methods. Make sure you understand the different types of sampling method we have. Bottom line, as we move forward this in this course, random sampling is something you're gonna keep on here over time. All right, that will do it for us for this video. Thank you for